If you thought about this, you probably figured out that even numbers are divisible by 2. In other words, an even number is a multiple of 2. So when you divide that number by 2, you will get a whole number, or what we call an integer. These are numbers that don't have fractional components. For example, 2, 3, 4, 5, all of these are integers, but 2.5 is not an integer because it has this fraction 0.5. So if you divide any given number x by 2 and the result is a whole number, then that number must be even. But if the result is not a whole number, then x must be odd. For example, 8 divided by 2 is 4, but 7 divided by 2 is 3.5 because 7 is an odd number. So let's assume we have these additional operations, floor and ceiling. The floor of a number, for example 2.5, gives us the value 2, and the ceiling of 2.5 gives us 3. So floor and ceiling are two ways to round the numbers, either rounding them up or down. So now we can write this algorithm to figure out whether a number is odd or even. First, we need to read the number and store it in x. I'm going to write that as input x. And then I'll divide x by 2. And then I'll take the floor of y. Okay, so I'm dividing the number x by 2 and then finding the floor. Now the condition is if z equals y, that means the number initially when I divided x by 2 did not need rounding. When you round it, you get the same number, right? So it was a whole number. So that means it was an even number. Else, if this condition is false, z equals y, it means z is not equal y. So when we take the floor of y, we ended up with a different number. That means that y had a fraction. So in that case, I know that the number must be odd. So let's take a quick example. Suppose the input x was 7. So now y will be equal to 3.5 because y equals 7 divided by 5. Z equals 3, floor of y, so z equals 3. So now when we reach this condition, z equals y, clearly they are not equal. So this condition will be false. That means this instruction will not be executed. We will go to the else statement and execute this instruction, which will display that the number is odd. But if instead x was 10, then y equals x divided by 2, that's 5. So z equals floor of 5, which is also 5. So now this condition will be true and we will display that the number is even. Now suppose we want to know the remainder of division. When you divide 3 by 2, the result is 1.5, right? But if we don't want to deal with those fractions, we can say that the result of this division is 1 and the remainder is also 1. What this statement means is that 3 equals 2 times 1 plus 1. So 3 is not a multiple of 2, but the nearest multiple of 2, you get it by multiplying 2 by 1 and then add 1 to it to reach 3. Okay, so we are interested in this remainder. Let's take another example, 7 divided by 2. That is 3.5, but if we don't want to deal with the fractions, we can say 7 by 2 equals 3 and the remainder is 1. Because 7 equals 2 times 3 plus 1. So this is the nearest multiple of 2, which is 6, and then we add 1 to it to get 7. Notice that both of them have a remainder of 1 when divided by 2. Actually, all odd numbers, when you divide them by 2, the remainder will be 1. And all even numbers, when you divide them by 2, the remainder will be 0. In math, this operation is called modulo or mod, and it returns the remainder of division. So for example, 7 mod 2 is 1, 3 mod 2 is 1, 2 mod 2 is 0, 4 mod 2 is 0, and so on. If you have any number n, the result of x mod n will always be from 0 to n minus 1. So when you divide by 2, x mod 2 will be either 0 or 1, odd or even. But if you take mod 3, the result could be 0, 1, or 2. If you take mod 4, the result could be 0, 1, 2, 3, or 4, and so on. Sometimes it is convenient to think of it as a wheel of numbers like this. Let's say we're interested in mod 5, so we divide this into 5 areas and place the numbers 0, 1, 2, 3, and 4. And then we can continue the numbers here, 5, 6, 7, 8, 9, 10, 11, 12. Notice that all the numbers here are multiples of 5. All the numbers here have a remainder 1 when divided by 5. So we have 6 mod 5, that gives us 1. 11 mod 5 also gives us 1. And of course 1 mod 5 is also 1. All the numbers here give us 2. So 2 mod 5 equals 2. 7 mod 5 equals 2. 12 mod 5 equals 2, and so on. So here 9 mod 5 gives us 4. Actually, any number below 5 will give us the number itself. So 0 mod 5 is 0, 1 mod 5 is 1, 4 mod 5 is 4, and then we reset the result back to 0. So 5 mod 5 becomes 0, 6 mod 5 equals 1, 7 mod 5 equals 2, and so on. So if you have any number, let's say 100 mod 200, because 100 is smaller than 200, the result will always be this number itself. So the result will be 100 here. 99 mod 100 equals 99. 100 mod 100, any multiple of that number, of course, gives us 0. And then 101 mod 100, 102 mod 100 will give us 2, and so on. Just remember that wheel. It always resets at multiples, and then you have 1, 2, 3, all the way to n minus 1. In most programming languages, we use this sign, the percent sign, for the mod operation. So 11 mod 5 is written like this. A clock has the numbers from 1 to 12. But after we reach 12, we can continue to 13, 14, 15. If we take those numbers, mod 12, we will end up with the correct number. For example, 13 mod 12 gives us 1. 17 mod 12 gives us 5, and so on. Let's say you want to calculate 550 mod 43. Using your calculator, you can first divide 550, divide that by 43, which gives you 12.7. Now ignore everything after the decimal point, so take 12 as the answer. Now multiply that by 43. That gives us 516. Now this is the nearest multiple of 43 to the number 550, which we're interested in. So now you need to find the difference between these two. So you have to subtract 550 minus 516. And the answer will be 34. Last time I gave you this exercise to find the maximum or the largest of 4 input variables. And this is the algorithm that I came up with, which is first to read the 4 input values and store them in these variables, n1, n2, n3, and n4. And then I created another variable called max, and I stored in it the value n1. And then one by one, I compare the other values. In 2, I compare it with max. If it's larger, I update max. If n3 is larger than max, I update max, and so on. So let's see how this works in practice. Suppose now the input was, okay, I'll have some random numbers. Let's say 4, 3, 2, 10. These are the input statements. Now we are here. Max equals n1, so max will be equal to 4. And then we have this condition. If n2 is larger than max, so n2 equals 3, so we compare 3 and max. So what we're saying, if 3 is larger than 4, which will be false, so this statement will not be executed. And then we go to 7. If n3 is larger than max, so now we compare n3 with max. n3 is actually smaller than max, so this will be false and nothing will happen. Then we go to 8. If n4 is larger than max, so n4 is larger than 4, so that statement will be true. So we will execute this statement, max equals n4. So now max will be equal to 10. And we're done. And then we should have a final step here, 9. So when we display the value of max, we're going to display 10, which is indeed the largest value among the ones that we have entered. You can try this with any sequence of 4 numbers, and max will always give you the largest one of them. Okay, suppose now I want to calculate the maximum of 10 numbers. What changes would you have to make here? You would clearly need more input statements and more variables to hold the values of those numbers. So we're going to need 10 variables, and then we're going to have 9 if statements, right? We will set max to be n1, and then we're going to compare the remaining 9 with that value in max. And imagine now we want to calculate the maximum of 100 numbers. Now you know how to write the algorithm for that, but it is very painful. Now if I give you that as an assignment, you're going to hate me. So there are actually more efficient ways to do this in all programming language. This is called repetition. Any part of your code that you need to repeat multiple times, you can do that easily. You don't have to repeat statements like here. We can just add a repetition statement. So instead of going through the code one by one, we could go back up and repeat some statements that we have already executed in the code. So let me show you how to do that. First, because I want that variable max to have the first entered value, I'm going to write that statement first. So first I'm going to read the first input. Okay, so I store the first number in a variable called x. And then I will create that variable max, and I will make it have that value. So this is a similar logic to what I did before, which is to read 4 numbers and then set max to be equal to the first value. Or what I can do instead, I can get rid of this statement and just right away store that first number in max. So it's exactly the same thing. I did not store the number first in x and then in max. Right away, I store that number in max. Now I will do the repetition. So I can do this. Repeat the following. Okay, I said repeat the following 3 times because here I want to read 4 inputs, but I already have 1 input thread already. So the remaining numbers are 3. So I'm going to repeat this 3 times. I'll read the number and store it in x. If x happens to be larger than the value stored in max, then I change the value of max to be equal to x. And after repeating this 4 times, the next statement is to display max. First, notice that in this code, we're only using 2 variables, right? Now let's say we have those inputs, 3, 10, 2, 5. The first statement is to read a number and store it in max. So that number that we read first, we're going to store it in max. So the value of max will be 3. And then we repeat this 3 times. We read a number and store it in x. So we read 10 and store it in x. And then we compare. X is larger than max, so that will be true, which means we need to change max to be equal to x, and that will be 10. We still have 2 more repetitions. So again, we read the number and store it in x. We read the number 2 and store it in X, and then we compare 2 with max. It is smaller, so nothing will happen. And in the last repetition, we read the number 5 and store it in X. And then we compare X with max. X is actually smaller, so that will be false and nothing will happen. So that's it for the repetition statement. Once we're done, we go to the next statement, which is to display max, and it is the largest value, 10. Okay, so now if we want to change this code to take 10 numbers instead of 4, we don't need to make a lot of changes. We just change the number of repetitions to 9. If we want to repeat this 100 times, we change the number of repetitions to 99. We don't need to create 100 variables. So repetition makes programming a lot easier.